documents operator. So far we've used this software as kind of like a platform to test the algorithm, and if we find that it is effective, then we can implement it in the computer-based learning environments to actually process those notes in like in real time and such. So one of the algorithms that we've looked at was the cosine similarity, so how to compute that, so how different notes are similar to one another, and the other one is the clustering algorithm. So the clustering algorithm will actually group these three notes together in terms of which one are more similar and which one are more different. So I can kind of like show you what the output looks like. So the data that comes out is basically, you can see here, our notes just got transformed from like a neat little sentence to like broken up words that are all common and all included in one together. So
can you zoom that at all?
Oh yeah, sorry. Let me see.
So is that the stream of words in that line? Is that
Yeah, I can read it for you. I can't really zoom it.
Oh.
It says here, paragraph, sort, state. So it's basically the output of all the algorithms that I just described. So it stemmed it, took out all the rules, so it bunched it up together with the n-grams and so on and so forth. And looking at your cosine similarity values, which are shown here, it actually says things like, well, your first and your second note was similar and the cosine value was 0.05. So on a scale of 0 to 1. So in fact, they were like a little bit semantically different. So for all of the notes that you've entered, it gives you like all the cosine similarity values like for each and every one. And the clustering algorithm will actually group them as groups to say things like, for instance, well, based on this, your second and your third note was more similar and was grouped up together, while the first note was kind of like separate or taken apart. And you can kind of like define how many groups that you want beforehand, so whether or not you want like 2, 3, or 4, and so on and so forth. So it's a way to kind of like explore how semantically similar like all of your notes are, basically.
Is this a correlation of the clusters? Is it how correlated they are, or is it?
Well,
or is it like a cluster analysis? What is the statistic associated with the cluster?
Well, the unit of similarity, like you can use different units, but the one that we used was the cosine similarity, which it kind of like computed the kind of like if you want like the correlation between your vectors. And the clustering algorithm kind of like takes all of those correlational values and it'll try and put what's called a centroid, like a mean. And it'll kind of like take out the mean and put it back in and take it out, put it back in, so on and so forth, like basically like 100 times maybe. To kind of like figure out, okay, well, which kind of mean is closer to these kind of notes and which mean is kind of like closer to this one, and kind of like maximize the difference between your groups. So that it kind of like gets at these different topics and such. Like to interpret your results, like we'd have to actually look at the word list to actually see like which word tends to cluster, which words tend to occur within each of your groups.
And do you get a visual representation of that?
It's shown here. So you have like all the different words.
So what's that big spike over there?
The blue one. I think it was pre-practice or province ask. Like it gives you like separately and stuff, and you would have to go back to your data to actually make meaning of this.
Yeah.
But it's kind of like a way to kind of like, you know, get at some of that meaning.
So I can see, I'm with you. The next question, maybe you're going to get into this, can this thing generate sort of like a frequency over time? Like if you have for instance, let's say you had a transcript of information that was 30 minutes long, and you wanted to look at that, can you have a time stamp in there as well?
Well, you would have to, first of all, look at the word list. I have it here.
Like beginning, middle, end, or if it shows where it occurs in the document?
Yeah, let me go back to the, I'll show you how you can do that.
You have to show me how, as long as it does that, that's sort of neat.
Well, it does do it. You would have to define like the label that corresponds to the time in your data set, and then just look at the word list and how they co-occur and such. I actually didn't show it. But it is possible to do like time analyses and stuff. It's just like I didn't label my data set like as like the actual time. You would have to use like an Excel spreadsheet to kind of like label each of your notes when they were written and such.
By hand. Boy.
In terms of visualizations though, other than just the graphical data, do they have any visual representations that kind of group the similar words like in I don't even know how to describe it, like a multi-dimensional model that says all these words are really close and they sort of have them like as a visual representation. And then here, these are far. Like, does it represent it that way so that you can sort of say, oh, these are all bunched together and these are not?
Well, to the best of my knowledge, I wouldn't know how to do it, but they might have an operator that comes up with these graphs, because there are graphing like opportunities and stuff. It's just I
Because
haven't.
the graphs might be really helpful to just sort of say, what is it that's going on here, rather than, you know, the other graph that you showed.
Yeah, and normally like you wouldn't do the analysis like in a linear fashion like I did. Like you would kind of like run it and then evaluate what you got and then kind of like make changes and run it again to kind of like get a better sense of how your data is coming out. Because obviously like, you know, there's a lot of information and it's very hard to interpret and stuff. So was there any other questions in regards to? So the last thing that I wanted to talk about before, hopefully you'll join us to go to lunch, is the classification. So the classification algorithm we haven't gone into yet, but it's what we want to try and get into. Basically the classification algorithm, it's kind of like you would gather a corpus of nodes that you would label and such. And using that algorithm, which is based on the cosine similarity value, you would kind of like be able to hopefully predict what is the category that like a new node belongs to, based on how similar it is to each of your clusters. So in theory, we could create like a cluster for like the nodes that were written appropriately and the nodes that were written inappropriately, to kind of like see how semantically similar like a new node is, to kind of like categorize it, like whether or not it's appropriate or inappropriate. Like if we test it out with the software and we're able to find out that in fact like the algorithm is or performs well, then we could embed all of these operators within the software to actually be able to do it in real time. Obviously like we haven't gathered enough of a large corpus to be actually able to do that reliably yet, but it's something that we're working towards. And this is kind of like what the cross-validation process looks like. So you can create this operator within RapidMiner to basically take your model and create it, train it, and then test their performance. So it'll actually run with like 80% of your nodes as the corpus, and then it'll try and predict 20% of it to see how it actually performs. So it's something that we'll work on like in future directions and stuff, and hopefully build like a learner model that would be able to actually categorize those nodes and stuff and provide like the needed instruction. And that was about it. That's like all my presentation. I have like a list of different acknowledgements, like people that help out with our project, different contributors, the funding sources, and so on, and different websites that you can go to get more information. So if there's any more questions that you have? Yes.
So this is an automated way of mining, if you want, of mining people's misconceptions, right? When they're trying to solve something, if you wanted to.
Well, assuming that you have like different texts, for example, that would reflect those misconceptions, and you have like enough of them, it might be that a cosine similarity would be like a good way to kind of like see like whether or not like a node has a misconception or doesn't.
Oh.
Like, you know, I'm not sure what's the best similarity index yet. Like there's different ways of going about it, and you can kind of like play around with the software to get those different units and stuff.
The cave thing that you just talked about, can you just go back a slide?
that the,
Okay, yeah, nearest neighbor algorithm. If you ran, like, say, novice data with that and versus expert data, that might be interesting in terms of what the differences are and how they cluster.
yeah, absolutely. Like, the cosine similarity would enable you to make like comparisons, like novice expert comparisons, for example, like in the context of bioworld, like how are they hypothesizing? Like is the context of, well, you might use Finkel protocols as the actual data source, so is their utterance actually similar, like across the novice and the experts, like how semantically are they related and such. Again, like the big thing, like if you're using this algorithm to predict, then the larger the data set, the better, because it makes it much more reliable.
Yeah, so you're building your model from a corpus of data, and then you use that model to predict future events.
Yeah.
That's actually, yeah,
That's the goal of it. Yeah.
very interesting. Yeah. Other questions? You guys are so quiet.
Yeah.
This stuff is so interesting.
So where this could really become handy would be if you were teaching a group of 150 or 200 or 300 students how to solve a problem, let's say, or solve some kind of a problem, or create some kind of an argument. You could then have them upload all their data and use something like this to mine that data very quickly to get an idea of what was common to know, what the misconceptions are, and that would rapidly help you decide what you want to do next time you.
Well, that's the hope of it. Like that's the ultimate goal. Like the software is really just a means to test like the algorithm itself and compare like different algorithms, like how they perform in each other. So like in theory, like if you can find like an algorithm that's able to predict like accurately like exactly what you said, like different properties of like how they're reasoning or what they write and so on and so forth, then you could then replicate all of those operators within your system, within your software, to actually be able to run some of these analyses like automatically and such. Yeah, that's great. So all of the slides and the video and stuff will be on the website. So if you're interested in like following through with some of these things, then you'll be able to.
On the Leeds website?
Yeah.